Hello students, welcome to Fun Scholar. So today we are going to discuss about the topic factorization for class 8 CBSE, but it will be also beneficial for ICSE board students as well. Okay, so let's start. So factorization, so I know that maybe the term factorization, like in term factorization comes with some formulas. Maybe you are imagining some formulas like x plus 1 and its square equals to x square plus 2ab plus b square. Okay, or some of you may have thinking like the formulas like x square minus y square, which have factors like x plus y and x minus y. Maybe all are like this. Okay, so we will dive into deeper by using these formulas and applying application with these formulas in this chapter. Okay, so let's start. And you may have confronted this chapter in the lower classes like for 6 or 7. So we will dive a little bit deeper into it. Okay. Okay, so let's think if you have 24 chocolates shares equally among your friends, what are the possible group sizes or to distribute them without any leftovers? So in basically if I have generally missed out the term that is factors. Okay, so in general in lower classes like from class 3, 4 or 5 or maybe in 6, we have all found out the factors of different numbers like 24. I can distribute 24 chocolates for 24 students for 1, 1, 1. Okay, or I can divide it like 2 plus 2 plus 2, 12 students. Okay, I can also distribute this as the 3 plus 3 manner for 8 students. Also 4 plus 4 manners for 6 students. Okay, by dividing it like for 1 we can't. Okay, 1, 2, 3, 4, 5 we can't, 6 we can. That's 6 plus 6 plus for 4 students. Okay, so done. So 7 also we can't, but we can divide it for 8 and 8. Okay, for 3 students, and for 12 for 2 students and 24 for 1 students. Okay, so let's recap this. When we were juniors, we solved this type of sum by using this method. Okay, it's generally we have to call it that like a staircase method. Okay, we used to solve this like taking prime numbers as the divisors and solve this like this. Okay, so this is the factorization, but now in class 8 we will have to do this like for algebraic terms as well and as well with the arithmetic terms. Okay, so let's go further. Next, so let's think 56 students need to divide into teams. Can you tell me the possible team sizes to distribute the players? Obviously, to solve this, we have to find the factors of 56. Okay, let's start it with 2. So it will be okay. So 56 can be distributed or can be transformed into factors like this: 2 into 2 into 2 into 7. Okay, or we can distribute it like if I take this like differently, like 4 into 14. Done. Or I can write this like 8 into 7. Okay, and there are so many, like 14 into 4 is already done. I can divide into teams. Can you tell me the, okay, so I can also divide like 28 into 2 and so many. Okay, so these all are the factors of 56. Okay, let's go further. Okay, if we can express the given numbers as the product of two whole numbers, then the numbers being multiplied are factors of the product. Thus, to find all the factors of a number, find all the pairs of numbers that when multiplied give the given number as product. As a result, the factors of 8 are 1, 2, 4, 8. Okay, so if you are given to find the factors of any the factors of any number, so you have to break that out with the products of different numbers. Okay, so like 8 can be broken down into 4 numbers like 1, 2, 4 and 8. Okay, so these are basically the factors. Okay, next, physical properties and changes. Okay, so this is a video, but this video is not not intended for this, so I am skipping this. Okay, and another, that is multiplication of integers. This is another video, and we generally know that how multiplication occurs. So I am here again skipping the video, but you guys can check out all the videos in the LMS. Okay. So rules of multiplying integers. So these are the basic rules which we have learned from for class 2 or 3, and we generally know that positive into positive becomes positive, negative into negative becomes positive, positive into negative becomes negative, and negative into positive are actually the same, that is negative. Okay, and they have also given the examples like this. Okay, so these are all the examples. So let's go next. Factor of a term. Let us consider a monomial, say 5xy, and we generally know that what does monomial means. Monomial means there will be only one related term. There will be no square or something. Okay, this monomial can be expressed as the two or more monomials in the following possible ways. Like 5xy can be expressed into 5xy equals to 1 into 5xy, 5 into xy, and 5x into y, or 5y into x. Okay, so there are 3 possible manner that which we can express this monomial. It follows that the possible factors of 5xy will be 1, 5xy, 5xy, 5x, y, 5y, x. Okay, so these will be, if we break down the 5xy, we will get all of these factors 1, 5, x, y, xy, 5x, 5y, 5xy. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, done. So we have broken down the 5xy, and what? These all numbers can divide 5xy. Okay, and it will not leave any remainder. Okay, so these all will be completely divisible. That means 5xy will be completely divisible by all of these numbers. Okay, let's go next. Okay, what is factorization for polynomials? Yes, this one is an important video, so I am going to play it.
this can be written as a product of two polynomials, then those polynomials will be factors of this polynomial. This can be written as x plus 1 multiplied by x plus 2. What you see on the board is called factorization. For now, let's not think about how we got this. Instead, let's focus on what factorization is and why we need it. X plus 1 and x plus 2 are the factors of the polynomial. How do you know if the polynomial is completely factorized? We just have to know two things. The degree of each factor will be less than the degree of the polynomial. We can see that in this case. It is very much true. Both the factors have degree 1, which is less than that of the polynomial, which has a degree 2. The second thing we need to know is that any of the factors cannot be factorized further. In this case, the factors x plus 1 and x plus 2 are in the simplest form and cannot be factorized further. If these two conditions are satisfied, we can say that the polynomial is factorized completely. What about the second question? Why do we factorize? Is there any reason? I think it looks neater. Look at the right hand side and compare it with the left. It definitely looks cleaner and more organized than the original polynomial. The second reason is interesting. Sometimes it gives us the zeros of the polynomial. What do zeros of the polynomial mean? Zero of the polynomial is a number when substituted in place of x gives us the value of the polynomial as 0. How does factorization help us get the zeros of the polynomial? Observe these numbers, plus 1 and plus 2. The opposite of these numbers gives us the zeros of this polynomial. The opposites of plus 1 and plus 2 are minus 1 and minus 2. These two numbers are called the zeros of the polynomial. Substituting minus 1 in the original polynomial, we get minus 1 squared plus 3 into minus 1 plus 2. That equals 1 minus 3 plus 2, which equals 0. Try substituting minus 2 in place of x of this polynomial, and you should get a 0 again. Remember, the factors may not always give us a 0 of the polynomial. This holds true when the degree of the factor is 1. Don't worry, we will understand zeros of a polynomial in a separate video. For now, keep in mind that it is one of the advantages of factorization.
Okay, so the video has been complete. So in this video we have learned that how does the factorization of polynomials works. Okay, and from this point we just have to note a point that degree of a factor will always be lesser than the degree of a polynomial. Okay, like this factor, and when doing the sums we will discuss this in a better way. Okay, so let's go further. So how do we factorize polynomials using grouping? Okay, and I'm not playing the video because we will going to discuss this while doing sums. Okay. Now, common factors and greatest common factors. Yes, we have already done it for arithmetic. Okay, like for the whole numbers or the prime, or using the prime numbers. Now we will do this or perform this with the algebraic terms. Like let us consider the terms 3xy and 7x. The possible factors of 7x are obviously that will be 1, 7x, 7 and x. And the possible factors of 3xy will be similarly 1, 3xy, 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 3y and x. Obviously, like for the 5xy we got 8 factors. Here we will also get 8 factors. So here we can see 1 and x are common factor for both the monomials. Okay, like for 1 and 1 is in the both side and x is also on the both side. So, the common factor of these monomials will be x and y. Okay, and they have also done the similar one for like another two monomials, that is 36x square y and 16xy. Okay, you guys can perform this in your home as well, in your copy, like taking any of two algebraic terms. Okay, and we will also discuss this in the further slides. Okay, the next, finding greatest common factor. List the factors, write down all the factors of each number, identify common factors and select the greatest. Okay, so the similar one. Like for like here we have 4 different algebraic terms where they have broken down or listed down all the factors of these algebraic terms and identified the common factors, like 2 for each of the cases, x for each of the cases and also y for each of the cases. So, the greatest common factor will be multiplying all of them and that will be 2xy. Okay. Going further. So, find the GCF of all of the given, like for the 15 numbers. Yes, you have to do it all by yourself. Okay, let me do some of them for you, like take number 4. So, we have 36x square. I can break it down like, okay, so let's write this. So, 36x square and 21x cube. I can break it down like 1, 2, 3, 4, 6, 6 and 8, 9, 12, 18 and 36. Okay, these all will be the factors of 36x square, and also I can take x and x square. Okay, similarly for 21x cube I can break it down like taking 1, 3, 7 and 21. Okay, and x square and x cube. Okay, so in the common factors I have 1 and x square, yes, and 3. So 3x square will be the greatest common factor of these two given polynomials. Okay, so similarly you can try it by yourself by taking any of the numbers. Okay, this is be like your homework. Okay. Next, to factor a polynomial using grouping, you arrange the terms in pairs where each pair shares a common factor, then factor out the common factor from each pair, finally looking for a common binomial factor to extract and factor out. Okay. So, rearrange the terms, group the terms, factor out the GCF from the each group, identify the common binomial, factor out the common binomial. Okay. So, this is another process where we are just after grouping them we are identifying the binomials. Okay. So, like for this case, so factoring by grouping, yes, they have just grouping it, then separating out the binomials and then rewriting it. So, this is called the middle term factor. Okay, we will try this like in our further slides. Okay, and the next one, factor by grouping. Okay, let's do some practice. Okay, like for this one, x cube minus 3x square plus 4x minus 12. You have to just group this like this. Take x square common and you will get x minus 3, and take 4 common, you will get 4 minus 3. So, x minus 3 is common between these two, and we will again take x minus 3 as common and we will get x square plus 4. Okay, so it's being done. Okay, it's just only factor by grouping, and we will discuss the middle term factorization in some next slides. Okay, the next one you guys can do this. You guys can do this by yourself, or I am just telling this. You just can take the common as 3x as the common, so it will be x minus y, and again for this case it will be 4 will be common, and here it will be x minus y. Okay, done. Okay, it's a doubt board. Achha, how do we factorize polynomials using identities? Okay, the identities means formulas. So let's watch the video here because this one is pretty much important. So let's play the video.
Before we begin to understand how special identities can be used to factorize polynomials, let me write them down for you. The first one says a plus b the whole squared equals a squared plus 2ab plus b squared. The second one says a minus b the whole squared equals a squared minus 2ab plus b squared. How do we use these identities to factorize polynomials? Look at this example. 9m squared plus 12m plus 4. Can we factorize this expression further? One way in which we can do it is to find the highest common factor of the three terms. But if you observe carefully, the HCF of the terms is 1. Is there any other way to factorize the polynomial? First term is 9m squared. We can also write it as 3m the whole square. The third term in the polynomial is 4. It can be written as 2 squared. We basically wrote the first and the last term in whole square terms. Why are we doing this? This is our first identity. A plus b the whole square equals a squared plus 2ab plus b squared. We got the first and the last terms in this form. Now we will have the middle term. How can we write 12m? Can it be written in terms of the first and last term and in this form? Yes, we can write it as 2 multiplied by 3m multiplied by 2. Observe how we split the middle term. We made sure that these two terms are present and the factor of 2 is also present. So we rewrite the polynomial as 3m the whole square plus 2 multiplied by 3m multiplied by 2 plus 2 squared. Does this expression look familiar to you? Look at the first identity. Our expression looks exactly like the right hand side of the identity, where a would be 3m and b would be 2. So a plus b the whole square is equivalent to 3m plus 2 the whole square. 9m squared plus 12m plus 4 can be written as 3m plus 2 the whole square. We could successfully factorize this expression using the first identity. The question is, how do we know that the first identity has to plus 4. We add the like terms to get 9m squared plus 12m plus 4, which is our original expression. Our answer is correct. 9m squared plus 12m plus 4 can be written as 3m plus 2 the whole square.
Okay, so this video was intended for using factorization using identities. Okay, so here they have, or we have used the identity of a plus b and its whole square, and the formula is a square plus 2ab plus b square. So by using the formula, by taking a as 3m and b as 2, we have formulated this to find the this equation. Okay, and after completing the formulation and solving, we have also rechecked this, like using the factors or multiplying the factors. Okay, so it's been done. Now let's go further. Okay, so this one just the part 2 of the video, and this is the similarly like using different types of formulas, and you have to understand that there are some formulas which will be used to using factorization, just like just like this formula, that is a square minus b square, or the identity difference formula, a square minus b square, or this one a plus b and its whole square, like a minus b and its whole square. Also these two cube formulas you have to memorize to use it. Okay, let's go further. Okay, factorize the following perfect square trinomials. Factorize the following perfect square trinomials. That means they have already told us that we have to use the square formulas here. Like for this case, like it can be written like x square plus 2 into a into b plus b square. We have taken a as x and b as 3. So the final formula will be looking like this: x plus 3 and its whole square. We can write it down like x plus 3 into x plus 3. Okay, done. Similarly, we can use this formula to solve this one as well, like 4x square plus 12x plus 9. We can take a as 2x and b as 3, and the formula will be looking like this: 2x and its square into 2ab plus b square. So the final answer will be looking like this: 2x plus 3 and its whole square. If I break it down, it will be 2x plus 3 into 2x plus 3. Okay, done. Okay, and the rest of these two you guys can do it by yourself. Okay, the next one. Now factorize the following differences of squares. Okay, and also the sum or difference of cube. Okay, so let's do this one first. Like for like this one, 64x square minus 81. So 64x square minus 81, we can take a as the 8x and b as the 9. So it will be 8x and its square minus 9 and its square. So the final answer will be looking like this: 8x plus 9 into 8x minus 9. Okay, because 8 square is 64 and 9 square is 81. Okay, and if you want to try it, whether it's not being instructed to do this, but some schools may have instructed to do this, like recheck this. Like again multiply this like 8x with the whole equation and minus 9 with the whole equation, and you will get this equation again. Okay. So the rest of 3 you guys can do it by yourself, and factorizing the sum or the difference of cube. Okay, before going this, because this formula is a little bit new as compared to the other ones, you have to remember these 2 formulas as well. Yes, they are the new formulas and you have to memorize this. Okay, that is a cube plus b cube equals to a plus b into a square minus ab plus b square, and a cube minus b cube will be a minus b into a square plus ab plus b square. Okay. So apply these 2 formulas. So the first one will be, the first one is a cube plus b cube. So we can write it down it like this, a cube plus b cube, and the final answer will be looking like this, a plus b into a square minus ab means 2x plus b square means 4. Okay, done. Okay, it's been completed. And the next one, like I am doing again for a minus 1, that is this one, 64x cube minus 1. So for 64x cube minus 1, take a as the 8x and b as 1. Okay, so if I do this or solve this, it will be looking like 8x minus 1, that means a minus b, into a square means, oh sorry, it will be 4x on, yes, cube. So it will be 4x. 4 4s are 16, 16 4s are 64. So the answer will be looking like 4x minus 1 and 16x square means a square plus ab, that means 4x plus b square means 1. Done completely. Okay, if you want to do this, like think this as 64x square minus 1, it will follow the formula which I have been trying it earlier, that will be 8x plus 1 and 8x minus 1. Okay, done. Okay, so steps of factorize using identities. So identify the pattern. Yes, you have to be careful to identify the patterns or the formulas to solve all of this. So identify the pattern, examine the polynomial to determine which identity applies. Okay, and the identities are there will be 5 identities, that is the 2 cube identities, 2 square identities, and 1 difference of square identity. So these 5 formulas or identities you guys have to memorize very carefully. Okay. Next, apply the identity and rewrite it this and simplify it further. Okay, and they have also given an example just like by x square minus 10. This one is very much easier, and it uses the difference of square identity, that is a plus b into a minus b. Okay, done. The next one. Okay, so next one, like they have given also the examples of these 2, and we have already done it, like applying the formulas or identities as well. Acha. Now we have how do we factorize a quadratic polynomial part 1. Okay, so let's learn factorization of quadratic polynomial by watching this video. Let's just watch the first video, so we will get to understand the other 2 videos as well. Okay.
We will now try to understand how to factorize a quadratic polynomial, sometimes
Okay, so all the process by which we can factorize the quadratic polynomials has been discussed in a smaller video of this. Okay, first they discussed that how does the quadratic polynomial look like. Obviously, it will be looking like ax square plus bx plus c, where we have three variables, and in the next part how we can factorize this, like just by like doing applying identities or doing middle term or by vanishing method. So these all methods we will be discussing in the upcoming slides. So let's go further. Okay. So factorizing a quadratic polynomial involves expressing it as a product of two binomials. The general form of the quadratic polynomial is look like this: ax square plus bx plus c equals to 0. And methods to factorize quadratic polynomials: obtain the quadratic polynomial and obtain the coefficient of x and constant term. Okay. Okay, factorizing a quadratic polynomial involves expressing this. Yes, we have already learned this. And the third step will be find two numbers and a and b such that a plus b equals to p and ab equals to q. Okay. Split up the middle term as the sum of the term ax and bx. Okay, maybe you guys have puzzled that what I am reading out this. So we will be doing this like applying the formula. Okay, so if I multiply the two given equation or factors like this, like x plus a and x plus b, we will be getting a quadratic equation and it will be looking like this. Then what we are doing, we are just keeping the likely terms out and making it as a factor. Okay, so it will be x square plus a plus b into x plus ab, and ab is the multiplication or product and a plus b is the sum of two factors. So just look at this, like if I write the general equation of a quadratic equation, so a means this and b means this and c means this. So c is what? C is actually the product of the two given variables, and this one will be b is actually the sum of the two variables, and x square is what? X square is just the nothing. So I can just write it down like this, like x square plus b by a into x plus c by a. And what does it mean? It means that I just divided the whole general equation by a, and we will be getting x square plus b by a into x plus c by a. And what does this mean? This means that b by a is actually a plus b, that means the sum of the two given variables, and c by a is the product of the two given variable. Okay. We will be discussing this in more, like in the next slides. Like for this one, in order to factorize x square minus 7x plus 12, we have to find two numbers p and q such that p plus q is equals to minus 7 and pq is equals to 12. Okay. So the clearly p plus q is minus 7. To find this, we have two numbers, that is minus 3 and minus 4, which will be making minus 7 as the sum, and 3 into 4 is 12, and minus minus will be getting positive or the sum. So it will be 12. We now split the middle term minus 7x of the given quadratic as minus 3x minus 4x. Okay. So after separating this equation will be looking like this, like x square minus 3x minus 4x plus 12. Okay. And then we have to group this out. So it will be x square minus 3x and after taking minus common it will be 4x minus 12. Then again take x common and 4 common, so it will be x minus 3 in both of the side. Then again take x minus 3 as common, or the distributive property. Generally we do not call it distributive property, yes we have learned this, but we generally call it as taking common, like x minus 3 and x minus 4 will be the final answer. Okay. So this is the complete factorization, looks like the factorization of quadratic polynomials. Most people call it as the middle term factorization. Okay, and why does they call it middle term factorization? Because we factorize the middle term and the last term as well. So that's why we call it as the middle term factorization. Okay, now the division, and maybe you guys have learned about the division in the lower classes as well, like for like class 6 and 7. So I am not playing the video here to waste the time. Okay. So divide a polynomial by a monomial, like here they have given examples by how we can divide a polynomial by a monomial, and that means that we have to divide each of the given term to the given monomial by the given monomial. Okay. So for this we have to divide 12x cube y to the power 7 by minus 3xy square. After that we have to divide 9x square y cube by minus 3xy square as well, and also plus 3xy square by minus 3xy square as well. Okay. Okay, so they have given us an example of this. So let's do this. We have 12xy square by 2xy plus 6xy by 2xy, and again minus 10x square y by 2xy. Okay, so after doing this we will get the answer as 6y plus 3 minus 5x. Okay, and if we arrange this we will be getting 6y minus 5x plus 3. Okay, what we have done, we just divided all the given terms by 2xy as well. So the first one is giving us, yes, 6xx will get, y will get eliminated and there will be only 3. So I have written 3, and here we will yy will get eliminated and there will be 5 and x. So it will be minus 5x. So all done. Okay. So here we have the doubt board. If you have any doubt, you guys can comment this or may ask in the class. So how do we divide a polynomial by a binomial? The similar process. I am not just playing the video here. Okay, so divide 6 plus x minus 4x square plus x cube by x minus 3. Okay, there will be the similar process, like just arrange the equation from in the descending order, like by the highest degree, that will be x cube will be the first, then it will be 4x square, then it will be plus x, then there will be 6. Now take a number which will be if we multiply that with the given dividends first term, that is x, will give us x cube and all of that. So if I take x square, we will be getting x cube minus 3x square. Okay, so x square will be multiplied with x and 3, both of them as well, and after that we have to subtract this or calculate this. It will be minus, the signs will get changed. So these two numbers will get eliminated, and here it will be minus x and minus and only x. After multiplying, it will be minus x square, and here it will be plus 3x. So after changing the signs, we have to done, and plus 6 will come out, and after that we have to take something to match the fraction, and that will be 2. So it will be minus 2x plus 6. Okay, now change the both of the signs and it will get eliminated and the remainder will be 0. So the factor or the dividend will be x square minus x minus 2. Okay, sorry, not dividend, they call it quotient. Okay, or the final answer. So the answer will be x square minus x minus 2. So they have done it like for the step by step by taking the step by step, and we have also done it by taking step by step. Okay, or not by understanding this, just try to understand this one. This one has been done by which I have followed the process, and you guys also have to follow this process as well to find the answer. Okay, the next one. Okay, or you can use the long division method, but I think by doing the long division, it would be better that not doing the long division method, to do the normal division. Okay. Oh, sorry. No. These all are the examples which were given. You have to do this like by long division method. Do the first one, that is x plus 3, and you have to divide x to the power 4 plus 4x cube minus 2x square plus 3x minus 5. Okay, I am doing just one for you, and all the rest of the one you have to do it by yourself. Okay, so first take x cube to match x4. So it will be x to the power 4 plus 3x cube. Okay, done. Change the sign. So it will be only x cube minus 2x square will come out. Okay, then again take x square. So it will be it will be x cube plus 3x square. Okay, change the signs and take minus 5x square down. Okay, 2 already been done, so now we have 3x. Now take minus 5x, so it will be minus 5x square minus 15x. Okay, change the sign, so cut it down, and we have now 18x minus 5. Okay, and to do this, how? Okay, just take 5. Minus 5 and take this. Okay, maybe it will leave remainder, so just take 18, so it will be minus 18x plus 54. These two will get eliminated, and here we will be getting 49. So 49 maybe will be the remainder. Okay. we've done it correctly. Okay, x cube minus 2x square okay, done. Rest of all you guys just can do this by your home. Okay, the next one. By the given polynomials, okay, let's do one again here. Okay, let's do this one, x minus 3 and the division of x minus 3, divide x3 minus 5x square plus 6x minus 2 by x minus 3. So first one will be x square, so it will be x cube minus 3x square. Okay, change the sign. Okay, it will be minus 2x square plus 6x. Okay, and take minus 2x, so it will be minus 2x square plus 6x. Okay, so after changing the signs, yes, minus 2 will be the remainder. Okay, done. Now doubt board. So if you have any doubt, so this chapter has been completed. So I hope you like the video, you have enjoyed the video, and all of your doubts are being solved out. And just keep practicing, and don't forget to like the video and subscribe the channel Fast Scholar Academy. Okay, goodbye.